Hello everyone, my name is K. Reddy, working as assistant professor in Theoretical Start Engineering College. This video I will explain power quality and fact subject. This is my channel, Accelerative Research. This view full playlist power quality and facts. This is power quality and facts in my previous uh, classes, previous lectures. We have Unit 1 and Unit 2. This video I will explain second chapter. This is the power quality and facts subject. R18 syllabus JNTH, 4th year, second semester have this subject. This subject, Unit 2, transmission lines and series and center reactive power compensation. Unit 2. In this Unit 2, basics of AC transmission lines. This concept I will explain this class. The remaining these topics already have in my playlist, my channel. Now I will start my presentation. Basics of AC transmission lines can be classified into two types. One is the power flow in parallel paths. Second one is power flow in mesh system. These two have power flow in parallel paths is the first. Power flow in mesh system. Power flow in parallel paths classified into four types. Next, power flow in mesh system also classified into four types. This is the first without controller. AC power flow with parallel paths. In this circuit diagram have two generating stations. This is generating station 1. This second one is the generating station 2. This is the load 1. This is the load 2. This is the power flow in parallel paths. Here in this circuit have two parallel paths. This is first one. This is second one. In this first one, impedance value is X. In the second transmission line, impedance value is 2X. In this first transmission, power is equal to 2/3 of power flowing in this transmission line. In this second transmission line, power flowing 1/3, 1/3. Okay. Here, the formula in power flow in transmission lines, formula power is equal V square by X sin delta. This is the formula. Power is inversely proportional to impedance. Here, observe here, impedance value X. When have less impedance, the power flow capacity is high, 2/3. When here increasing power, impedance is equal to 2X, the power flowing in this transmission line is decreasing. Power flow is based on inverse of the various transmission lines impedance. This is the basic concept of power flow in transmission line. Power P is equal to V square by X and sin delta. This is first part. Next, power flow control with HVDC. Power flow control with HVDC. This is in these two transmission lines. This first one is uncontrolling transmission line. This second one is the controlling transmission line. In this controlling transmission line, power flowing to this generating station 1 to generating station 2. This is the rectifier. It converts AC to DC. This transmission line, it transmitting DC power. In this transmitted DC power, it converts DC to AC by using this inverter. Okay. This is the HVDC transmission lines. In this HVDC transmission, we will increase power stability. At the same time, this HVDC transmission lines are suitable high efficiency only above 500 kilometers. In small distance, this HVDC transmission line is not suitable because the cost of this transmission, the cost of power electronic device will more. That's why this HVDC transmission line is suitable for above 500 kilometers. This figure shows the same two paths, but one is this have HVDC transmission line, and HVDC can also help parallel AC transmission line to maintain stability. Okay, this is first diagram without controlling. This is the HVDC transmission, controlling transmission. This is power flow control with variable impedance. In this variable impedance, in this second transmission, capacitance here adding this in this series transmission line. When adding capacitance value, the impedance value will decreasing because Z is equal to R plus JXL minus XC. When we are adding this capacitance value, the variable impedance value will decreasing. When decreasing impedance value, automatically the power flow capacity will increasing. Power flow control with variable impedance. In this variable impedance, we are adding capacitance and we decreasing transmission impedance, decreasing impedance or reducing impedance value, automatically power flow capacity will increase. This is the fourth type of power flow in parallel transmission lines. Power flow control with variable phase angle. In this second transmission, this is uncontrolling device, this is controlling device. When phase angle it reduces, the power flow capacity will increasing. Okay, this is power flow. This total related to this formula. Power is equal to V square by X sin delta. This is the delta phase angle. When decreasing phase angle, the power flow capacity will increasing. This total, these four are transmission lines. One is the without control, second is HVDC transmission, third one is transmission control with impedance, fourth one is the variable phase angle. These four related to parallel transmission line. These four related to power flow in parallel transmission. Now I will explain power flow in mesh system. This is the power flow in mesh system. In this mesh system, here one place, this two generating stations with the different locations and load also different location. In this circuit diagram, have this is the bus 1 and this is bus 2. This is a bus 3. In bus 1, here A is the generating station. Here B also generating station. In the circuit C is the load. In this generating station A, generating 2000 megawatts. In this generating station B, generating power is 1000 megawatts. Total 2000 plus 1000, total 3000 megawatts load here. Okay. The capacity of transmission AC is the AC2 here see this transmission line capacity is 2000 megawatts. Next this BC here B2 C this transmission capacity is 1250 megawatts. This AB transmission line capacity is 1000 megawatts. This is the basic power flow in mesh system. In this system, the transmission capacity is here AC 2000 megawatts, BC 1250 megawatts, this AB 1000 megawatts. This AC is 2000, here only 1400 megawatts. In this transmission have not overloaded. Here also next this AB 1000 megawatts, but here flowing only 600 megawatts. This transmission also not burden, not flowing, not overloaded. Next to this BC, this BC is capacity is 1250, but here power flowing is 1600 megawatts. This BC transmission line, this transmission is overloaded. Okay, because this capacity of transmission line B2C is 1250 megawatts, but here power flowing is 1600 megawatts. This transmission line impedance is 5 ohms. This A2C transmission line is 10 ohms. This A2B transmission line is 10 ohms. Okay, here overloaded. By using some power electronic devices, fax devices, we will reduce this overload. Next slides, I will explain. This is the power flow in mesh system. This second diagram is previous diagram. Okay, this is the fax device control diagram. System diagram with thyristor controlled switched capacitor, series capacitor in line. TCSC thyristor controlled series capacitor in line. Here, this is the generating station 1. Generating power is 2000 megawatts. This generating station B generating 1000 megawatts. This is the load 3000 megawatts. Now, in this A2C here, A2C 2000 megawatts generating capacity. Here adding series capacitance. Okay, here minus 5 ohms added. Here total previous 10 ohms, 10 minus 5. Now final value is 5 ohms impedance. When decreasing impedance, the power flow capacity is increasing. Now power flow capacity is 1750. Here without this capacitance value 1400 megawatts. Okay, when adding this capacitance value, the power flow increasing. Here next A2B is 250 megawatts. The remaining 250 megawatts flowing through this AB transmission line. Here also AB transmission line is previously 600 megawatts in the circuit in this TCSC 250 megawatts. Next here B2C, the capacity of transmission line also same 1250. In the circuit I have overloaded. In this circuit is 1250. This is the example values, not practical values. Okay, this is example purpose. This 5 ohms added. This transmission line capacity is now 1250. Okay, the circuit is not overloaded. Okay, this is the one type of control, TCSC, thyristor controlled switched capacitor. Now I will explain another controller, power flow in mesh system. This is system diagram. In the second diagram, system diagram with thyristor controlled switched reactor line BC. In this BC, we added thyristor controlled switched reactor. In this circuit, normal power is the 1400 megawatts flowing from A to C and A to B 600 megawatts and B to C 1600 megawatts. Here adding series capacitor, series inductance. Okay, 5 ohms here. Next here 7 ohms. When increasing reactance here, series inductance, the power flowing capacity automatically decreasing because power is inversely proportional to reactance. Okay, when adding here reactance, the power flow capacity will decreasing. Now power flowing is 1250 megawatts. In previous, we added capacitance, the power flow capacity we increased. This second type of controlling, we added inductance value. When here 5 plus 7, total reactance is 15 ohms. Total impedance is 15 ohms. When increasing impedance value, automatically the transmission line power capacity will decreasing to 1250 megawatt. This is the not exact value, not overloaded this transmission lines. Final A to B 1750, A to B 250. Next this B to C 1250 megawatts. This is second type of control. Next, this is the third type of control, power flow in mesh system diagram. Okay, this is third type of diagram. Here the phase angle is minus 4.24. When decreasing phase angle from example 10 degrees to minus 4 degrees, when decreasing this phase angle, automatically the power flow capacity will increasing in transmission lines. This is the system diagram with thyristor controlled phase angle regulator in a transmission line. This is third type of power flow control in a mesh system. This is normal without controller system diagram. This is the with control with the phase angle regulator system diagram, thyristor controlled phase angle regulator. When decreasing phase angle, the power flow in transmission line capacity will increasing. Total in mesh system have 3 control schemes. One is the adding capacitance value. Second one is the adding inductance. Third one is the phase angle control. Okay. This total concept is related to power flow in transmission lines, power flow in parallel paths, and power flow in mesh system, basics of transmission line. Okay, thank you for watching this video.